Hey everyone, today we are solving LeetCode problem number 198, house robber. In this problem, we will be given an integer array nums representing the amount of money of each house. Okay, let's say we have an array given to us 1, 2, 3, 1. This is nums given to us. And we have to return the maximum amount of money you can rob tonight without alerting the police. Okay, so these are four houses and this is the amount of money each house is having, and we have to rob this street in such a way that we are not alerting the police. And how the police is being alerted? If we rob two adjacent houses, let's say if we rob one and two together, or two or three together, the alert will go to the police. So we have to rob these houses in such a way that no two adjacent houses are robbed. Okay, so if we work over this example, we have 1, 2, 3, 1. If we rob 1 or 3, we get 4 as a total amount. If we rob 2 and 1, we get 3. If we rob 1 and 1, we get 2 as a total amount of money. So 4 is maximum. So we will rob this house or this house to get the maximum amount of money. And in this case, we are not robbing two adjacent houses. It means we are not alerting the police. So that this is our valid answer to this problem. And it's a very important question, has been asked in many companies. You can see Cisco, Apple, Amazon, Google, Adobe, Microsoft, Bloomberg, etc. Okay, so how do we approach this problem? Let's say we have this array 1, 2, 3, 1. So this is our bigger problem. It means that we have these number of houses and we have to get the maximization out of it. We get the maximum amount of money we can get from these houses. Okay, so if I give you these houses 1, 2, 3, so this is also the same problem, just this like problem set is smaller in this case. This is also the same problem. We have two houses and we have to rob in such a way that no two adjacent houses are robbed, and we have to maximize the amount of money. Okay, so from this we got to understand that we can break this problem in a smaller problem, that we have sub problems in it. Okay, we have sub problems, and those sub problems, if we try to solve using recursion, we can come up to the solution of bigger problem. Okay, now let's say we have 1, 2, 3, 1. Okay, we have to get answer of this problem, this array of houses with this much amount of money. Let's say if we start from this end, it's up to you whether you want to start from right or left. At this house we have two possibility: either you rob this house or you skip this house. If you rob this house, one amount of money will be added to your pocket and you are left with this subset. But in this subset, if you rob this 3, you are clear that you cannot rob this 3 house, because this is adjacent to the last house number, house at index 4, index 3, sorry. So if we have robbed this house in this case, and 1 will be added to our pocket, and now we cannot rob this 3, and we will be allowed to rob from these houses. So let's say our bigger problem is solution function with complete array, and our index is equal to n minus 1, which is the last index. So our sub problem will be solution of n minus 2. If it is n, then it will be n minus 2. And it's just index here. Okay, let me draw it again. 1, 2, 3, 1. So this is our bigger problem, and we are starting from this. And let's say this is our index 0, 1, 2, 3. 3 is the index. So this is, what is this? This is going to give us the solution of this function call. Solution with array where index is equal to 3. So equivalent to solution of 3. Solution from 0th house to 3rd house inclusive. Okay. So we are at index 3. We have two possibility. Either they rob this house or we can skip this house. If we rob this house, so we will be able to get one amount of money plus solution of index minus 2, because this we have robbed, this we cannot rob, and these houses we can explore from 0 to 1 inclusively we can rob. Solution of 1 till 1. Okay, in this case we are not robbing 1, like maybe house at index 3, so we are allowed to rob this 3 and the leftwards. So solution of 2 is the answer, and 1 is not robbed, so no, like no score so far, no amount of money we have so far. So from 0 to 2 inclusively we can rob, or if we rob 0 to 1 inclusively, then we are allowed to skip 2 and we are robbing 3, which is having one amount of money, so that is we are adding. So from solution 1 we have 0 to 1. We can skip 1 or we can include 1. If we include 1, we have 2 plus, so this one is already having, we have 1 plus 2 plus solution of 1 minus 2, which is minus 1. Okay, if I skip this, then I have a solution as solution of my index minus 1, 1 minus 1, which is 0, solution of 0. And solution of 0 is two ways. Either we are skipping the 0th house or we are including the 0th house. Skip, rob the 0th house. If we rob the 0th house, we have 1 plus 1. Okay, and if we skip the 0th house, it will be solution of minus 1 again. Now we have to rob, we have to get solution from 0 to 2nd house. Now we have two possibility. Either we rob the house at index 2 or we skip it. If we skip it, it will be equivalent to solution of 1. If we rob it, then it is equivalent to 3 is the amount of money we got plus solution of 2 minus 2, which is 0, solution of 0. Here also we have two possibility. Either we rob the 0th house or we skip it. If we skip it, it is equal to solution of minus 1. Is if we rob it, it is equal to 3 plus amount at money at 0th house is 1 plus solution of minus 2. We can rob the house at index 1 and we can skip it. If we skip it, it is equal to solution of 0. In this way we can approach our recursion, and here if you see that initially I rob the amount of I rob the house at 3rd index. So if I rob the house at 3rd index, I cannot touch the house at 2. So till 1 I am allowed to rob the house. So this is the amount of money we got from 3rd house. So from solution of 1 we can get from 0 and 1 house we can rob. From 1, if we rob the 1 house, we have solution minus 1, which is if the index is less than 0, it is 0 amount of money we can get. Or if we skip it, we can rob the house at index 0, so which is 1 plus solution at solution at 0, which is also 1, and it is minus 2, solution minus 2, and solution minus 1. Here if you will see that we are getting a lot of overlapping subproblems. Here we are solving solution 1, then we solve the solution -1, then so we solve the solution 0, and again and then we get solution -2, and after that we got solution -1, solution 2 is being solved first time, solution 0 is getting repeated, solution 1 getting repeated, solution -2 getting repeated, -1 getting repeated, and 2 is also getting repeated. So there are overlapping subproblems in this approach. So it means that we can memorize our answer at every step. So if I write a pseudo code for that we have to find the solution. Let's say array is our global variable, which is containing number amount of money every house is having, 1 2 3 1. Okay, then let's say int id x. Initially the index was 3 in our example. Okay, so let's say this is our recursion call. So in this way we got two possibility. Either we rob the house at this index or we skip it. So maximum of that we are going to get. So we have to return math dot maximum. Maximum of, if we rob the house at this index, so that would be ARRIDX. That is amount 1 we have robbed, plus solution of IDX minus 2, because we have to skip one house. This is one possibility. And the second possibility is, do not rob the house at this index. After, in that case, all of these houses we are allowed to rob. Solution of IDX minus 1. That is, we are skipping this house and we have to get answer from these three, from 0 to 2, 0 1 2. Okay, this is our recursive call. If we are robbing the house, we get something added to our pocket and then explore further. If we are not robbing the house, then explore further. And what is the edge case? Here, if IDX is less than 0. Okay, in this case it was -1, -2, -1. In that case, we are left with no houses. So we can directly return 0. There's the zero amount of money we can get from a solution. So this is the recursion for us. And in this recursion, if you see the what is the variable thing for our call, we have index as the variable thing for our call. In every call, we have different value of indexes. And if you see in the problem statement, we are given a constraint that this index value, it means the number dot length will go till 100 and greater than equal to 1. It is going from 1 to 100. So if I take a variable array, if I take an array of size 101, I can easily store my answer against every index. It means index value will go from 0 to, it means our index can go from 0 to 100. We are taking a DP array, you can say DP array of size 101. In that case, we can memorize our solution function call against every value. So before that, we are going to store this value in the DP of IDX. And before that, I will check if DP of IDX not equal to null. If not equal to null, we can directly return DP of IDX. So in this way, we are memorizing our calls. And if we are memorizing our calls, we are making the time complexity to order of n in this case. So what is time? Time is order of n once we have done the recursion with memorization. And what is space complexity? That is also order of n, because we are using recursion here. Okay, let's quickly implement this approach, recursion with memorization. Here in the problem, we have this rope function where nums is the array where each element is representing the amount of money that corresponding house is having. And we have to rope in such a way that we are not robbing any two adjacent houses. So let me write a solution function. This solution function will give me the answer, maximum answer like maximum amount of money we can get if we rob houses till this index, and we are like having nums dot length -1 till last index. So from index zero house to the last house, what is the maximum amount of money we can get? So in such a way, we will break down our problems. Return this private integer solution, integer array nums and int idx. Okay, if idx is less than 0, it means we cannot get any money. We will return 0. Otherwise, return math.max. In the max, we have two possibility. If we rob the current house, we get nums.idx plus solution of idx minus 2. This is the first parameter that we have to check. And the second possibility is we do not consider the idx element. In that case, it would be idx minus 1. Solution of idx minus 1, not semicolon. So we have these two possibility. If we try to submit it, I just wrote the recursion in 2's power n approach. Solution of idx minus 2. I have also passed nums array. On the sample test cases, it is working fine. And if I submit the problem, I should get TLE because I have not added any memorization. Okay, I got TLE because we are having a lot of overlapping sub problems in this case. And the shortcut to get like what we have to memorize is that all the variable part in the solution call. Here, index is the variable stuff. And what is the value of index that we can cache? Index value can go from 0 to 100. So let's say I'm taking a DP array. I'm taking an array of integer type because that will also help me make a null check. Integer DP. And here, let's say DP is of size new integer of size 101. And before returning, I will just memorize this answer against IDX. And as along with the memorization, I also need to check whether I have already captured this answer or not, whether that is already cached or not. If dp of idx is not equal to null, it means we have this answer and we can directly return dp of idx. Let me submit it again. Okay, if I submit it, getting submitted successfully. Okay, hope you understood the problem. Thank you guys.